We now know that the RESTful API is going to be at the center of our application. It's the principal means by which our user interface can interact with the database and the business logic on the back end, and the principal means by which the back end can deliver content to the user interface. Now, there's a lot of different ways we might approach the design or specification of that RESTful API, but rather than using something sort of informal and ad hoc, I want to spend some time talking about a formal way of defining what that API looks like, and that's called the OpenAPI specification. Just a quick note that this OpenAPI spec used to be called the Swagger spec from the organization that first proposed an early version of it, so you might still see things called Swagger this and that, but OpenAPI is really the specification that we're after. And in particular, we're going to look at some tooling that allows us to use the latest version of that specification, which is 3.0 point something. So this is the OpenAPI homepage, and it's a kind of a jumping off point for a lot of different resources related to OpenAPI. And one of the things that's interesting about this specification is that it's an open source thing. So this is the GitHub page of the OpenAPI initiative, and you can see here that the actual specification is itself available to the public. So if we click through here, we can actually go see the details of the specification itself, which is really just a big document here. Current version 3.0.3, you can click through to that to get the details, and this is just one long document that describes how that specification works. Now, in order to get at the who cares question, I want to show you an API that was defined using this OpenAPI spec. And this is from the Swagger people, so again, they show up pretty regularly, and the example API that they've defined here is for a pet store. And you can see that there's some descriptive information here, and then the majority of this document are these entries that show us the various endpoints that are available in this API. And they've split them up into pets and stores and users. But within any one of these, let's look at pets, I guess. Within this grouping, we can see that there are posts and puts and gets and deletes, different kinds of requests, different HTTP methods that are in use here, and they're being sent to a specific URL, right? So the URL here is identifying a resource. In the case of the pet/pet, we're identifying a collection of all pets, right? Because that's a collection type resource as opposed to an individual pet, which has a pet ID associated with it, which would just be an element of that collection. But you can see how we can post to pet, we can put to pet, we can do a variety of different things to pet. We can also do similar things to the store, to users that are in the system, and so forth. So we're seeing a nice graphical representation of the verb, the method, and the URL, and then a little brief description of what that endpoint does. Now, if we drill into this, we get some more details. So we can see here, first of all, that there's no parameters that are sent to this particular endpoint. Whereas if we were to look down here for information about a specific pet where there is a parameter, we'll see here that now there's a description of that parameter. It says we've got to supply a pet ID in the URL that's going to be used to look up that specific pet. Well, let's go back up here to the post. We can see that there is a request body that's required. Now, the fact that this is a post request, it usually means that we're going to invoke this when we want to create a new instance of this collection. So we want to create a new pet. Well, in order to create that new pet, we've got to provide some information in the request message. And in this particular case, the API is expecting there to be a JSON encoded string that includes information about this new pet. And we can see here that the authors of this particular OpenAPI spec have supplied us with some examples of how to do this. So we're going to give an ID value, some sort of a category, a name for this pet, the URL of the photograph of this pet, some additional tags, and we can see that there's both this example schema this example value, as well as a schema that describes this thing in more detail. So we can see here that the ID is an integer, the pet's name is a string, the photo URLs is itself an array containing strings that list the locations where you find the pictures of this pet, and so forth. So we have access to that information, and that's specified by the OpenAPI spec for this endpoint. We can also come down here and find out information about the responses that we might expect to get back from this. One of them is an invalid input. Something was messed up with the information that was provided in the request, and the server is allowed to come back and say, hey, sorry, you've got a problem there, and we can specify that that is a valid response that comes back from the server that we'd probably want to use in the user interface to report an error to the user, something like that. Let's go back to this this get request by pet ID. You can see again that we have to supply the pet ID in the URL to get the element of the pet collection that we're interested in. And then the responses that can come back from this are a little bit more elaborate. We can get the normal response, a 200 response code from the HTTP protocol means things worked okay. And in that case, we're seeing that the example value that we might get back is quite similar to what we just saw up above. We might also get a 400 error, which would mean that we gave an invalid ID in this case. 400 is kind of a generic client-side error. So if we gave it an ID that that had some numbers in it and some letters as well, when we weren't allowing letters in the IDs, we'd have the server return this. Or if we gave it a valid ID, or what looked like a syntactically valid ID, like a series of digits, but there was no such pet in the database, the server could come back and say, sorry, 404, I couldn't find this particular pet. So you get a lot of really helpful and handy details about the behavior of each of these endpoints encoded here in this OpenAPI specification. So what we want to be able to do is do the same thing for the class project. Let's take a look at the underlying code behind this. So I'm going to open up this code editor, and you can see here that this is a YAML formatted file. It's basically a syntax that it makes it easy to come up with nested structures like arrays and objects and so forth, but in a really simple kind of textual format. And the OpenAPI spec works either with a YAML file like we have here, or with a JSON file, or file containing JSON. And they can express basically the same kinds of information. There's some differences between them. And actually, you're free to use whichever one you would prefer. I'm going to actually look at this a little while to show you the YAML file, and then I'll also drill into a specific example that uses JSON. Same exact information can be presented in either case. So you can see here that this file, it's got a very specific format, a very specific content and structure that's going to be verified for you by some tooling that orbits around this OpenAPI specification. And so the idea here is that this text file, you can think of it as a source file really, is going to specify what that API looks like. Now, one of the things that you can use this source file to do is generate this kind of nice documentation just automatically. It's part of built-in tooling that you can have access to get this nice documentation. You can also use this same source file for other purposes. For example, in some cases, you can use it to generate client-side code that knows how to talk to the API on the other side. In some cases, you can use it to generate stubs for the server side that would create, for example, the routes and the route handlers in a framework form that you could then go in and fill in the specific code to go and access the database or execute whatever business logic. You can also use it for testing. You can also use it to generate collections of endpoints for use in a tool like Postman. So this one file can really be used to generate a lot of different kinds of helpful information. For our purposes, we're kind of thinking about it at this point as a means for us to become quite specific in what we want our API to look like, but there's method to the madness, right? You'll get great documentation for your API. It'll be much clearer when you go to implement your Happy-based API server, what's going to be expected, what's going to be transmitted, what's going to be returned, what error conditions can take place, and so forth. So a lot of utility comes out of spending the time defining this OpenAPI specification for your project. You can see here just a little bit, one of the sections in here is the paths section, and this kind of gives us a description of the endpoints that are available. And within the paths, the colon here basically indicates nested objects, you could think of it that way, or nested, kind of a nested class in a way. But within paths, the first thing we've got here is /pet. So that's the endpoint, basically the /pet endpoint, and it corresponds to the endpoint that we've just spent some time talking about. There's a couple of different ways of sending information to that pet /pet endpoint, right? We can post to it and we can put to it. And you can see here that the next level of nesting inside this structure shows us a post and a put. Within the post, which is what we looked at before, we saw that we could get different things back from it, like a 405 to say, well, you got invalid input going on there. So the details of that post, and we're going to unpack this in more detail with respect to the rideshare project, but the details here in this file basically specify all that information that's necessary to define that endpoint and make it clear what that endpoint can do. Here's the similar thing for put within the get specification. We also took a look at the get for a specific pet. And we can, actually there's a little shortcut thing here that says we can just scoot right to the appropriate place in the editor where we'll find that. And now you can see there's another path /pet ID, right? That's what's reflected here. And in this case, we're asking for a parameter. We've got to supply a pet ID, so /pet/17 or something like that. So in addition to some of these other things, we're going to have a new section that we didn't see in the previous one called parameters that refers to, in this case, the parameters that are being passed right in the URI's path. So we have to say the name of the parameter, which has to match what's going on up here. We're saying that we'll find that parameter in the path. We can also send parameters as query parameters, after the question mark in the URL. We can send them as cookies, we can send them as headers, and we can specify all that right here inside of the OpenAPI spec. We can give a description here, ID of the pet to return. Well, that's going to be used to generate the documentation. So ID of the pet to return shows up right here. We can say, is this optional or required? Well, in this particular case, this is an endpoint designed specifically to give back data on a specific pet. So we do have to make this required. And we can also provide a little schema. And this is basically just we've encountered that word in the context of talking about databases, but it's a kind of a generic term that just describes the format of some data. And in this particular case, we're just going to send an integer. And that integer more specifically is going to be a 64-bit integer, but it's sufficient here to just say type integer. And that will allow the OpenAPI specification to clarify exactly what information is going to be expected there. We can then use that as part of our implementation. And we can see here also that we've got some different responses that could come back that correspond to the responses listed at the end of that section of the generated documentation. So we can send a 200 response code, which basically means everything worked okay. We've got a description here and then some information about the content. And we're going to talk about this some more in the context of rideshare. But we can also send other types of responses to say, sorry, I couldn't find a valid ID, or sorry, the pet you asked for doesn't exist. So those are some of the things that we can do with the OpenAPI specification to clarify exactly what our API should look like. And again, we also get for free some of this nice tooling to generate documentation and so forth. One or two other resources here that might be helpful for you, and I'll put links to these in the topic information on the course website. The Swagger folks have come up with a pretty nicely formatted sort of condensed version of the specification that's really helpful for learning how the pieces and parts work. And then there's also this kind of neat graphical view of the OpenAPI that's also kind of fun to play with. You can actually drill into these different levels of the API itself. So for example, we were looking at paths, and that expands out here to a particular path, and then within the path we can create get, put, post, delete, options, head, patch, trace, servers, parameters, right? These are some of the verbs or the methods. We can drill into that a little bit further, and we can see that we can specify the body of the request, the responses to the request, and so forth. So I don't know how useful this will be. It's kind of a neat way to visualize the structure of the OpenAPI spec for a particular API. So you may want to take a look at that just to kind of help you navigate around as you're working your way through the definition of the APIs. Now, nobody wants to write these files manually without any assist, and there are a whole variety of different tools out there. Some are open source, some are commercial. One that I'm going to show you here that is really handy and is completely open source is a package for Visual Studio Code that has really nice support for defining these specification files and has code completion and IntelliSense and all that kind of stuff. So the Visual Studio Code edition is called the OpenAPI/Swagger editor. Pretty well regarded, 100,000 downloads and really highly rated. So if you are already using Visual Studio Code, or if you're okay using Visual Studio Code, this I guess would be a recommended place for you to start. There's also an OpenAPI mode for the JetBrains tool set that I have seen but I haven't used. And again, there's some dedicated tools that you can get either to use online or to download. And again, I'll put some links to those things in the topic for the course. But so this is what I've already installed here to use as my mechanism for writing these files. So I'm going to close out of this, and that's going to show us the interface for the pieces and parts that I've defined so far for rideshare. And I'll give you the source for this file as well, so you have a kind of a starting point. But you can see here that I defined a few things about user, but I kind of tried to flesh out just kind of one small corner of our application and have focused on the vehicle type, which is just a thing that says, you know, this vehicle is a pickup truck or an SUV or a sedan or a convertible or whatever. So you can see, just like I showed you with the pet store example from Swagger, within the vehicle type, I've got several endpoints defined. There's vehicle types, and I can post, and I've got both collection endpoints and element endpoints. So this is going to refer to the whole collection of vehicle types, and we're going to send a post request to it. And we know that that usually means that we're going to create a new vehicle type. We can also get at the list of all the vehicle types. So a get request to that same endpoint is going to get all the vehicle types back. I like to make these plural. That's just a convention. If you don't care for that, they're welcome to choose something else. But because the collection is, you know, has a multiplicity of entries in it, I think it makes the most kind of semantic sense to make these plural. So let's take a look at the post request in more detail. We can see here that we've got a little summary tag that says what this does, some additional description. You notice that this has actually got some highlighting going on in it. You can use Markdown here to have fancy formatting in your descriptions. There are no parameters for this particular request because we're just creating a brand new vehicle. And in the request body, we've got to pass some information. I've got to say, what is this vehicle type called? So you can see here, I've defined a format that's going to be encoded as a JSON string for transmission with the request, and it's going to have a vehicle type and then a value for that vehicle type. You can see here there's also a schema defined for it, like I showed you in the other example, that says vehicle type has to be a string. Now the responses that can come back. Well, if everything works okay, I'm going to get a 200 response sent back. And in this particular case, I've decided to kind of echo back the data that I sent in the request up here. And then I'm also going to return the ID for that particular vehicle type. Remember that when we're adding this vehicle type to the database, we aren't specifying a particular value for this. We're just going to use a synthetic key that's going to be generated by the database when it creates this new row in the vehicle type table. So in order to make that information available to the user interface, for example, to allow it to update a drop-down list of vehicle types with the appropriate ID value so that when it adds a new vehicle to the database, it can send back the appropriate vehicle type foreign key, or vehicle type ID as a foreign key, I'm sending it back to the user interface as part of the return value from this particular query. I could also define in here, you know, other error codes that would indicate problems. I haven't taken the time to do that. Another endpoint is a get endpoint for the vehicle types, and this thing is going to just return the vehicles that are in that, or the vehicle types that are in that list. You can see that this return value is actually an array of objects, and in this case I only have one showing up in this example, but in practice you're going to have, say, a dozen or 20 different vehicle types, and they would all show up as objects in this array of vehicle types that's returned from the API. Notice that I don't have a well, I don't have a GET request for a particular vehicle type. I kind of judge that to be really sort of unnecessary. I'm not going to generally want to fetch just a single vehicle type. In most cases, I just want to get all of them so that when I'm displaying a drop-down of the vehicle type to the user who's, say, entering a new vehicle into the system, they're going to want all of the existing ones. It's not going to be something that I'm going to try to fetch down individually. However, it's possible that I might want to update a vehicle type that already is out there or delete a vehicle type that's not being used. So the additional routes that I have here in the vehicle types section of the API are a patch, which is going to update an existing vehicle type, and a delete, which is going to delete an existing vehicle type. So if we look in patch, you can see here that I've got now a parameter that's coming from the path, and it's required, and it's basically the ID of the vehicle type I want to update. I also need to be able to send information about what columns of that table, essentially, I want to update. And so I've got to have a request body, also marked as required. And this is basically the same request body that's coming in when we create a new one. When we did the post request to vehicle type, I want to also send something similar to that to this patch request to the vehicle type with that particular ID. And on the server side then, the application code is going to go in and make a modification to the table that contains vehicle types and set the vehicle type to this new value. And then I got some similar things coming back here. I just decided in the case of the successful operation, it would just come back and give me the new value. It would come back and say type SUV here. And if I got a 400, it would basically mean that I gave you a bogus vehicle type. This should actually probably be a 404. And then finally for delete, kind of similar in the sense that I want to delete a particular vehicle. So I've got to tell the server which vehicle I want to get rid of. And in this case, there's not really anything interesting to send back. I guess I could send back the ID of the vehicle that I had deleted, but the user interface already knows what the ID was because it sent it in the request. So I'm just indicating here that I could either get a 200 or a 400 in the case that it actually worked successfully or didn't. But there's no additional payload being returned from the server to the user interface to indicate any additional information because it's not really necessary in this case. So those four endpoints are defined in a file that captures these specific types of behavior and the information that's being passed around. So let's take a look at what that looks like. So this is the output from the tool that I installed from the Swagger module that I installed in Visual Studio Code. The source code is just an ordinary. In this case, as I mentioned before, you can use either a YAML file or a JSON file. They both work perfectly fine. Whichever one you'd like to explore it's totally up to you. And I wanted to show you how the JSON version worked here. There's also a little toolbar that comes with that OpenAPI plugin that gives you information about some of the details here. So you can see here I've got information about the paths, information, and we'll talk about components and so forth in a second. But these allow you to kind of drill down into the structure of this specification file in order to be able to see the particular endpoints and the particular methods that are being implemented and responses and other things that are defined inside this JSON file. So I've collapsed down this specification JSON file so you can kind of see the top level structure. There's some other top level elements you can add here, but these are very common ones. The first thing you have to have is basically a way to tell the tooling that's going to use this file which version of the OpenAPI spec you're using. So I've got version 3.0.0. You can add a little bit of additional metadata to the specification. So I've got this info section. It takes a title and a description and a version number and just kind of gives some additional information about how this or what this specification actually is. And you can see that that's actually reflected in the output here, right? So rideshare API is coming from this title, and then the description clarifies that. Notice that, as I mentioned before, you can use Markdown in here. So I can come in here and, I don't know, boldface this, and we should see that down here in the output, the previewer automatically updates that. So you can do any kind of markdown thing that you'd like to do in here and make that look like code. And you can see that updates to look like code. So that's handy. And it also keeps track of the version number. So this is not the version number of the spec. It's the version number. I mean, it's not the version number of the OpenAPI spec we're using. It's the version number of our specification. So I've called this version 0.1.0. And you can see that that's shown up here in the output as well as the fact that this is the OpenAPI spec version 3. Okay. The tags allow us to group the different paths into coherent groups. So I've defined two tags, one called user that has rideshare users and one called VehicleType that stores rideshare vehicle types. And you can see that, so user, rideshare users, and VehicleTypes is coming from here. And then what I do for each of the routes that I'm showing in these sections is I say, hey, this route has this tag. And that allows it to group things into the appropriate slots in the documentation. Okay. Let's look next at these components. So when we're defining what a particular request or response or the body of a request looks like, we're going to basically give information about things like this is an array of objects, and those objects have the following properties, and some of those properties might themselves be other arrays or objects, and we can come up with a fairly elaborate structural representation of the valid information that's going to be sent back and forth in the API. Now, it would certainly be possible for us to specify the details of that every place those things came up. But if you step back a second and think, well, let's just think about the user, for example. It's got a first name and a last name and an email address and some other things. It would be really redundant for us to sort of copy and paste the definition of a user in multiple places in our specification. So what we can do is define that user component one time, and then we can just refer to it from multiple places in our code. So the place where you do that is a section called components, and then within that there's a schemas section. And you can see here I have 3 schemas. Again, the schema is just a fancy way of saying the structure for something. And in particular, I have one for users. And you can see here, so I've got a user schema, it's got a description, it tells me that it's an object, not an array of objects, it's an object at this top level, and here's the properties in that object. So an ID, first name, last name, email, password, phone number, and so forth. And all I've specified for these things are the types at this point. You can put more metadata in here that describes things like fields that are required, fields that are optional, patterns that they have to match, that kind of stuff. But I've just tried to keep it fairly simple here. And then I've also supplied an example, and this is what's showing up in the output in our viewer for the documentation. So for example, if I say I want to do a get of users, I should see as the structure for the return value an array of objects that follow this example, and that's exactly where this came from. Okay. So this allows us to kind of avoid having to duplicate these definitions in a bunch of different places in our code. And we'll see how that's used in a second. I've also got a really simple one for the vehicle type, and it has just 2 properties, the type or the ID of the vehicle type, and then actually I want to call this vehicle type instead of type because type is used elsewhere. And then there's an example here of the pickup truck, right? And we saw where that starts to show up in the output documentation. And then the other thing I have up here is an error schema, and it is basically used whenever I want to return an error value back to the user interface. I want to have it take a specific format. In particular, all I've defined here so far is just to say that the error is an object that contains just one property whose name is message, and it has a type string. And as an example, it might look like this, right? So this could be the JSON response that comes back from an endpoint that says something weird happened. Okay, so I've got those 3 components. Now let's take a look at the actual paths. And I want to look specifically at these vehicle type endpoints because these are kind of, all of the ones that you'll probably want to use for vehicle type. So let's drill down into, unless first of all, I guess that within this paths section, we have the actual paths that are the locations in the in the RESTful API where these details are defined. So we can send requests to users, or users in some ID, or vehicle types in some ID. And each of these are going to implement one or more of the verbs, right? So we're going to have gets and puts and so forth. We know for the vehicle types endpoint, we're going to have a post and a get. So if we drill into this one level deeper, we'll see there's the post and there's the get. Now let's start out by looking at the post. We'll drill into this a little bit further. Summary, create a new vehicle type, and that's where that shows up. Here's a description. Again, we can use Markdown in our description. So if I drill into this, you can see here that there's some Markdown stuff taking place here corresponding to this input. Here's the tags for this endpoint. It's a tag of type vehicle type, which is what asks the user interface generator here to group those things together. Now, when we're posting a new vehicle, we want to include the details of that new vehicle, and the way we specify that is with the request body. So if we drill into this, we'll see that the request body has some structure to it. In particular, there's going to be some content information. The content in this, let me drill into this a little bit more, and we'll come back and talk about it. So the content of the request body in this case is going to be the new vehicle type. I'm going to create a new one. So I've got to give it a name that's going to be used to insert it into the database. So within the content, we can see first of all that the schema, the description of what it's going to be shaped like, it tells us that it's going to be an object, and that object is going to have some properties, in this case just one property called vehicle type, and it's going to have a type of type string. And you can see here that in the request body portion of the documentation, it's telling us, it's showing us the example here that I put in. But we can also switch over to look at the schema, which is going to tell us that we have to have an object with a vehicle type field that's of type string. Okay, so that very clearly lays out what this request is going to have to look like. We got to send a post request to the vehicle types endpoint, no ID because we're creating a new thing. And we have to include in the request itself a JSON object that satisfies this schema, that satisfies this particular format. The other thing that we've got going on here is this application/JSON. That's going to tell us basically the format or the content type for this particular request. Content type is something that the HTTP protocol uses to indicate what's in this message. So when you send a request to a website and you get back an HTML page, the content type is going to be text/HTML. When you send a request to a website and you get an image back, the content type is going to be image/JPEG or image/PNG or something like that. And then on the client side, the browser uses that information to determine what is it going to do with this thing that got back from the server. Should I try to render it as HTML? Should I try to render it as an image? And obviously if the tracks don't line up, it's going to do something wrong or find some sort of an error in that process. But that content type basically says, here's what you should be expecting. And in a RESTful API, we're almost always going to send information back and forth as JSON objects or arrays of JSON objects if we have a multiplicity of things coming back from the server, for example. And the way that we specify a JSON object is using a content type of application/JSON. Notice that because this content element is itself an object, we might actually have multiple content types that are being returned. So we talked about how the original notion of an AJAX application, or this kind of early Web 1.0 thing, was asynchronous JavaScript and XML. We could send content that was in XML format. So there's a whole variety of different ways that we could do that. But for our purposes, we're pretty much always going to just use application/JSON. And that just says, here's what we're sending you. In this case, it's part of the request to the server. So the server will see that this has got JSON in it and decode that and use that to insert the new vehicle type. But we'll see that we're also going to supply that information on the way back out so that the browser can deal with the returned content appropriately. Okay, so we've now defined the information about what we're going to do. We're going to post. where we're going to post it. We know that a post to a collection endpoint means creating something new. So we've got to also include the information we want to use to create a new vehicle type. And then we also want to specify what kind of things we might get back. So in the responses section here, we've specified what's going to happen when we send a 200, which is a everything worked great response. This can get a description that's showing up down here in our documentation, and it's also got a content section. It's going to be application/JSON. It's going to be a JSON string, and the format of that is going to be defined by the schema. And now we start seeing where we're going to leverage those components that we defined before. In the past, what we've seen is that these schemas are going to say it's an object, it's got these properties and so forth. But because we're going to do a lot, well, not a lot, but we're going to use this vehicle type structure multiple times, rather than defining that in here and then having to duplicate it elsewhere, which violates the don't repeat yourself principle, right? What we want to be able to do is just do that once. And you can see here, this is kind of a path. So it's in the component section under schemas under vehicle type. So if we go back up here to our component section and look under schemas, let me collapse this down so it's a little clearer what we're looking at. Under vehicle, so components/schema/vehicle type, here's the details on what that vehicle type schema looks like. Right? It's a schema and it's got this description. It's an object. It has an ID and a vehicle type. Here's an example of what that looks like. And so by using this path to the vehicle type schema, what we're doing is we're referring to that specific schema here without having to duplicate it a bunch of times. And that's what we see coming out here. We see this example value from the schema, from the component itself, and we can look at the schema as well and drill down into its content to see that it's an object that has an ID and a vehicle type. So the way to do this is to supply that path, and then you use this $ref for reference, and that leading $sign, it's just a convention to say, hey, this is something a little bit out of the ordinary. It's a reference to somewhere else. It's kind of metadata that points you elsewhere in the specification format. All right, so that takes care of this post request. Let's take a look at the get request and how it's specified. So remember get, and we're getting the collection of vehicle types. I decided not to define a get endpoint for a specific vehicle type because you're almost never going to, well, I can't imagine a scenario where you'd need that. But we can see if we drill into the get request, first of all, it doesn't take any parameters as we expect, and it doesn't have to send any information along with it to ask for all of the vehicle types. So we don't have any body content, and the only thing we're going to get back is a response. And you can see we're kind of reusing that schema that we defined before. The difference in this case is that when we get back in our go back to our post request, when we get back something from here, the response is an object containing the single vehicle type that we just added, including the ID that comes back from the database. In the get request, we want to get all of the vehicle types, right? Because this is a collection endpoint. So you can see here that it's the same kind of object-looking thing, but it's embedded in an array. So we're saying here that we're going to get back an array of objects that have this form. And we can see that in more detail if we look at the schema and drill down inside of here. We can see, okay, there's an array, and it's got vehicle types in it. And if we drill down further, well, a vehicle type has an ID and a vehicle type. So let's look at the specification for the get request. Again, summary, tags to group it properly. We're not sending in any body content or request content, so all we're going to specify here are responses. Here's the success response, the 200, says it worked okay. And the content of this guy is still going to be an application JSON object. The schema is going to have to specify a little bit of additional information. We can't just go ahead and use this vehicle type directly, because that vehicle type is an object, and we want to have an array of objects. So we're going to, inside of our schema, we're going to say, well, what's going to come back from here is an array. And then when you define an array, you have to give it an items list as well, or an item specification. And here is where we'll finally use that reference to the component that defines a vehicle type. So the schema itself is an array. The elements that are contained within that array, the items in that array, are objects that are defined by this vehicle type schema. And that's what gives rise to this, this kind of output and this example value that's being generated. All right, let's take a look at the patch request. This is going to be used to update an existing vehicle. Because we need to update just one vehicle at a time, we're going to ask for the vehicle, sorry, not a vehicle, but a vehicle type. We're going to ask for the vehicle type's ID. So that's got to be there in the path. And we'll see that that's a parameter that's being passed in, that's required. We also need to send along a body in this request that contains the field that we're going to change. In this particular case, it's really simple because there is only one field really that we can change, and that's the vehicle type itself. But we still need to tell we need to tell the API that. So here's the request body. It's, well, there's the example. If we looked at the schema, you can see that this is just a vehicle type and a string. So that's what we're going to send with our request, and what we're going to get back is either an OK, in which case we're going to give back the entire vehicle record. I don't know why that might really be that necessary, because it would presumably be the case that we would know the details of how we updated it, but why not? Or we're going to get a 400 code of some kind. All right, so let's drill into that. Let's look inside of vehicle types. We're trying to do the patch endpoint, and it takes some parameters. So we can see here, here's our patch endpoint under vehicle types. Summary, it's a vehicle type thing, and these are the parameters. Let's drill into here. You can see that we need to get an ID, and that's what we've just shown here kind of in the documentation for it. We're going to look for an ID in the path, not as a query string parameter or something like that. And its schema is very simple. It's just a simple integer, right? So we want to say that. And we also want to indicate that it's required. But it doesn't make any sense to try to patch a vehicle if we don't say what vehicle it is. So this information is what gives rise to the documentation we saw up here. ID, it's an integer, it's required. Then in the request body, this is going to be quite similar to what we sent in when we did the post request to create a new vehicle type. Sorry, lots of drilling down here. So the content of the request body, again, it's going to be a JSON string, and it's shaped as follows. It's an object. That object has one property in this case called vehicle type, whose type is string. And then I'm also supplying an example that illustrates what that might look like. So we're sending, in addition to the parameter that says which vehicle type we're updating, we're sending a new vehicle type string that says how we want to change it. And then in the response section, you can see for the 200 case, we are going to return application JSON, a JSON string that is a vehicle type. So again, we're reusing that schema definition that we defined earlier. Or we might also expect to find a 400 response, which doesn't have anything meaningful to return with it, so we just describe it as something that's a possibility. Now notice that I didn't use the vehicle type up here in the request body. The reason being that the vehicle type is defined in such a way that it requires both an ID and the vehicle type. Well, because I'm only sending an update to this particular vehicle type, and the only thing I want to be able to change is the vehicle type string itself, I defined a very specific schema that included just that vehicle type. I don't want to have to send the ID along as both part of the URL and redundantly as data inside of the request body. Then finally, we've got the delete endpoint, which is defined here just below. So here's delete, and if I expand on that, we'll see that the delete endpoint is part of, or the delete method is defined as an action for this endpoint, right? We sent a patch to this endpoint to update an existing vehicle type. We're going to send a delete to this endpoint to remove an existing vehicle type from the database. So we have to send a parameter. So just like before, we're going to have a parameter called ID that's defined in the path itself, it's an integer, and it's required. Now, you notice that there's some redundancy here. It turns out that you can actually make use of this components mechanism to define parameters that you can reuse. So I'd recommend that you take a look at the documentation for that and see how that's done so that you avoid having to duplicate this information many times. The response that comes back, or the responses that are possible, we've defined a 200 to say that it was deleted and a 400 to say we couldn't delete it. Again, not really clear that there's very much useful information that you could return in this case. The user interface already knows which vehicle you're going to delete, so it could like take it out of the list of vehicles that it is maintaining for that drop-down that lets you manipulate the vehicles. And you don't really need to send anything back from the server in order for that to work properly. So I've elected to not do that. A few comments about this process of using the OpenAPI spec to define your RESTful API. First off, this is going to look a little complex. There's a lot of detail in these files, and that's true. That said, though, once you sort of work your way through your first CRUD pattern, right, do the create, read, update, delete on a particular resource or a resource collection, you'll kind of have it under your belt, and you'll know what the pieces and the parts are. I'm going to also ask you to read the specification so you kind of know what the possibilities are, and you'll know how to get back to those in the documentation so that you can use them correctly. You'll also, if you use a tool like Visual Studio Code, there's really good IntelliSense kinds of things, so it'll give you the list of options that you can have at any particular point. There's also the fact that you can, in this setting, you've got the integrated documentation that you can view really easily to verify that what you're sticking in the input file is actually reflected in the way that it's being processed. So you'll know if you're doing something wrong because there'll be some sort of an error that's generated to tell you, sorry, this doesn't belong here, or this is out of sequence, or whatever. So again, using a tool like this can be super helpful for that purpose. Also want to make sure that you are aware that this is a source file for your project, right? It's just as important as your JavaScript code or your SQL code for the database. So you want to include this in revision control, right? Include it somewhere like in that top level API directory. Create a file that has this specification in it, and then as you make changes to your API over the course of the project, go ahead and make sure you keep this updated properly so that the documentation is correct for the API as it's written as your API evolves. You don't have to swallow the whole elephant at once, right? You can kind of take it in bite-sized pieces, build a little bit of the specification, verify that it's looking the way you think it's going to look by checking the documentation, and go back and add some more. Don't forget that this whole process is driven by the requirements for the project, right? At the end of the day, the project's requirements themselves are what determines what go into your API. So you want to constantly be going back and asking yourself, am I adding things that I need to have in order to satisfy some requirement, or can I leave something out? So for example, I mentioned a couple times that I don't think it's necessary to have a get endpoint for an individual vehicle type. You're never going to ask for that in the actual application, so don't define it. So you don't have to just by rote kick out every possible part of the CRUD pattern for every resource and every element of every collection. Use good judgment as to what you have to include and what you don't. When it comes to answering those questions, ask, what's the endpoint? Is it a collection or an individual element? What methods do I need to implement to satisfy the requirements for the project? And once you have that kind of basic framework set up for each of the endpoints you're adding, go back and say, well, what information do I need to send from the client to the server in order for the server to do its job? That's going to determine the request body. When you're thinking about what you want to return back from the server, ask what information are you going to need in your user interface to be able to display information to the user, or even information that you're going to just keep behind the scenes in response to that particular request. And then use that to define your responses from that particular endpoint. So what I'm describing is kind of a top-down design pattern. Start with the requirements, ask what information needs to be moved back and forth between the client on the browser and the server itself, then come up with the specifics of the data that need to be moved back and forth. In order to do that, you're definitely going to want to go back and look at your database schema, right? Because all the information and specifics of the data that's being managed by the server is defined in that database schema. So if you have things in your schema that you're never including in a request or a response, you want to check to see, well, do I really need that thing in the first place? And if you do, then, well, you probably want to figure out where you're going to be transmitting that information back and forth.